Welcome to this video. My name is Roel Dobbe, and in this module we will explore how important public values such as fairness, inclusion and accountability are connected with the technical systems that manage our energy grids. In this video we will make these complexities more tangible in an engineering context. The aim is to understand how the design of control systems for congestion management shapes energy justice outcomes. Let's consider a concrete example from a Dutch electricity network. Based on a weather forecast, the grid operator anticipates congestion in a part of the network that connects both a solar farm and a wind farm. On a warm, windy day, both are expected to produce more electricity than the cables in the network can transport. In response, the grid operator contacts the solar farm manager with an order to disconnect part of the solar farm in exchange for compensation for the lost production of energy. This congestion issue reoccurs more regularly. Each time the solar farm is contacted to reduce the production in exchange for financial compensation. At some point in time, the solar farm manager and the wind farm manager meet somewhere in town and they discuss the congestion in their shared network. The solar farm manager realizes that it's only she who is being asked to reduce production, and the wind farm manager wonders whether he is missing out on the compensation. In this example, we already see relations to the different concepts of energy justice. First, distributive justice. The utility has chosen a particular way to control congestion, distributing the burdens and the associated compensation on one possible producer over another. Second, procedural justice. It may not have considered procedures to understand the potential of other producers and to engage and empower a broader set of actors, for instance locally, to participate in the control system. Third, restorative justice. In this case, the utility has little historic knowledge nor responsibility of possible injustices experienced by actors in the network that could be relevant to address, or which could even worsen if not considered. And last, recognition justice. And perhaps, in this case, the utility does not yet recognize wind farms as a potential partner in preventing congestion in the network. So, this example can be understood as the outcome of a control system, a prediction of a possible congestion issue, like the fault shown here in this distribution network, which triggers the identification of potential control actions, such as lowering solar production or lowering wind production. The controller selects an adequate action and implements it, hoping that the congestion issue is mitigated. In this way, the distribution of benefits and burdens is shaped by the logic designed into the control system and by how operators use it. The controller behaves according to the objectives and constraints designed for by engineers. And over time, these logics may lead to repeated patterns, as we saw in the example, that accrue benefits and burdens across actors in a network, which may ultimately result in potential energy justice issues. So we can better understand the relationship between control and energy justice in two ways. Firstly, we can ask the question what justice means in this context. Is there even a set of principles or established norms to help the engineers and operators structure the design of their control logic? But also, second, who participates in the first place? How are the benefits and burdens supposed to be distributed among those who do participate? And what's the role of local democracy in this? Secondly, if a good idea of the required norms is available, a controller should be able to address it through its process model, which describes how the controller understands the process that it is trying to control. It consists of four fundamental aspects. First, how are the definitions and norms for energy justice translated to objectives and constraints that the controller should respect and realize? Second, are there sufficient actions available to the controller in order to properly address any possible emerging congestion situation while also respecting justice norms? And third, what measurements and data sources does the controller need in order to anticipate and determine that congestion is taking place and to understand justice concerns in a timely fashion? And last, what model does the controller need to properly understand justice issues? Which may be a computational model, but it could also be the understanding of a human operator to inform proper actions. Any control engineer or operator in charge of an energy justice control problem should be able to properly answer and reflect on these questions. Ideally, the design of such control systems aligns with existing laws and policies and the democratic principles on which these are written. However, energy justice is still a relatively nascent topic. In practice, energy injustices may emerge before principles are fully developed into actionable norms and practices. And therefore, insights from operations may inform the development of future norms and rules. Now let's summarize what we covered in this video. We used a congestion management example in an electricity distribution network to show how energy justice concerns can emerge in the design and operation of energy management and grid control systems. We related these concerns to the core tenets of energy justice. And lastly, we walked through the core structure and logics of control systems and reflected on how energy justice can be understood and addressed at the level of core conditions of the controller's process model. Thank you very much.